These are the working solutions for the solving trigonometric equations formative. So in the first question, there's two ways that we could actually try to solve this. The approach I'm going to take is that I can see that there's a common radical on both sides. So I'm going to subtract 12 root 3 on both sides. So I'm left with 6 tan x is equal to minus 6 root 3. And then here I'm going to divide both sides by 6. So I'm left with tan of x is equal to negative root 3. So we can't solve for x directly. Here we can only get the reference angle, so tan of alpha. So remember that tan of alpha, tan of a reference angle, is going to be the absolute value of tan of x. So in this case, tan of alpha is going to be root 3, because that's root 3 is the absolute value of negative root 3. So alpha is the inverse tan of root 3. So if we go back to our special triangles or special ratios, alpha is going to be 60 degrees. So how do I get x? Well, I'm going to draw my Cartesian plane using cast as my reference. Since the reference of tan in the original question is negative, we need to look for where tan is negative, so that's in quadrants 4 and 2. So I'll just go ahead and draw a quick diagram to show that's my reference angle there, 60 degrees, and there's my reference angle, 60 degrees. So that applies to x1. We'll do the first one. In the second quadrant, that's going to be 180 degrees minus 60 degrees, which is 120 degrees. So that's one answer. And the second answer is in the fourth quadrant. We're going to take 360 degrees minus my reference angle, which is 60 degrees. So I'm left with 300 degrees. So therefore, x is equal to 120 degrees or 300 degrees. In our second question, here we see that the sign is actually squared. So this is a hint, or we know that this is going to be a quadratic equation. So one of the first things that we could do is replace. Actually, before we get there, I'm going to to solve for a quadratic equation, we want one side equal to 0. So we're going to add 1 to both sides. So here you get 2 sine squared x plus 3 sine x plus 1 is equal to 0. And then off to the side, we're going to factor this. So I'm going to let t equal sine of x. So this becomes 2t squared plus 3t plus 1 is equal to 0. So we're going to factor by decomposition. Since my a value is not 1, so my product is 2, the sum is 3, and the two integers that multiply the 2 and add to 3 is 2 and 1. So that implies that we're going to break up the 3t. So break up the 3t to be 2t plus a t plus 1 is equal to 0. And with decomposition, we're going to group this into two binomials and do a common factoring off of that. So in the first binomial, I'm going to factor out a 2t. So I'm left with t plus 1. In the second binomial, the best I could do is just to factor out a 1. But that's fine, because I'm left with t plus 1, which I see my common factor of t plus 1. And then I'm left with 2t plus 1. So that's the equation factored. So we're going to come back to working it out. I'm going to replace t with sine of x. So in this case, I can get sine of x plus 1 times 2 sine of x plus 1 is equal to 0. So because now we have it factored, we could say that sine of x plus 1 is equal to 0, or 2 sine of x plus 1 is equal to 0. So let's solve the first equation on the left first. So here you get sine of x is equal to minus 1. In this case, a couple of ways you could sort of remember that you could use the table of values. Or I like to still draw the graph of sine, so it looks something like that. It's -1 at 270 degrees. For the second part of the equation, or second equation we have to solve for, here we get, so 2 sine of x is going to be -1. Divide both sides by 2, so we get sine of x is equal to -1/2. So again, we can only get the reference angle from this. So sine of alpha is going to be the absolute value of my sine of x, which is going to be 1/2. So alpha is going to be the sine inverse of 1/2. And going back to our exact ratios, alpha, or the reference angle, is going to be 30 degrees. So do a quick sketch over here using CAS as my reference. In this case, sine is negative, so we're sine negative. It's negative in quadrants 3 and 4, and we just determined that the alpha, or the reference angle, is 30 degrees. So that's over there, that's over there. So remember, the reference angle is always to the x-axis. So this implies that now my two solutions for x, one solution is in quadrant 3. It's going to be 180 degrees plus my reference angle, which is 30. So the 210 degrees is one answer. And finally, the second one is in the fourth quadrant. So in there, it's going to be 360 degrees minus my reference angle of 30 degrees, which is 330 degrees. So in this case, we actually have three solutions. So therefore, x is equal to either 210 degrees, 270 degrees, or 330 degrees.